In this segment, we're going to learn how to reverse an array by taking an in-place approach. Now let's try solving the same problem but by using an in-place approach. In-place approach means source initially points towards Uttara. So after the change has been made, that is after the values have been reversed, source must still point to Uttara and the changed values must be in Uttara. This is called the in-place approach because the change is being done in the initial source array. So here, look how the structure of my method has changed. If you notice, I no longer have the return type of an array over here. The return type is void because over here I am not going to create a new array. Okay, because it's an in-place approach, the change must be over here. I cannot create a new array. So when I send Uttara, when I send the source array, which is Uttara, the change will be done in Uttara. Hence, in the end, I don't need to return anything because Uttara is already stored in source. Hence the return type is void. I want you guys to pause the video at this point and try to solve this on your own. Try to reverse the array by not creating any new array and make the changes within this array under Uttara. So what we can do is we can maintain a variable I and a variable j. The variable I will start at its first index, which is the index at 0, and j will be at its last index 4. Then what we can do is we can just swap the values. So 50 will come over here and 10 will go over here. So we have swapped the first value with the last value. Next, we will increment I by 1 and we will decrement j by 1. So I will point at index 1 and j will point at index 3. And then we will swap these two values. So after the swap, notice that the array has become reverse of the previous array. So these are the steps to solving the problem in an in-place approach. Now I want you guys to write the code on your own. This is the code to the in-place approach. I have set I to 0, I start with 0, and j starts with s.length minus 1, which is the last index. So j starts at 4. I have not written the condition because I want you guys to figure this out on your own. And after each iteration, I will increase by 1 and j will decrease by 1. Now in the first iteration, I points to the first index and j points to the last index. Now I have to swap the values. If you remember, swapping two values must be done in 3 steps. So I need to send the value 10 over here and 50 over here. So first what I'm doing is I'm storing the value of s of I in temp. S of I means s of 0, which is 10, in the variable temp. Next, I'm copying the values in this way. S of I equals to s of j. This means s of 0 is equals to s of 4. So s of 0 will become s of 4, which is 50. So 50 will be copied over here. After 50 is copied, I need to copy the value 10 in the last index. Last index is at j. So s of j is equals to 10. And after these 3 steps, my swapping has been successfully completed. After this, my loop will run again, but I will increment by 1 and j will decrement by 1. So I will point at index 1 and j will point at index 3, and these two values will be swapped. Next, these two values are swapped accordingly. In the next step, I will point towards 2 and j will also point towards 2. You see over here that no swap is necessary. So the last swap was when I was 1 and j was 3. So when I and j are equal, I no longer need to swap any values. So how long did we have to do the swapping? We had to do the swapping as long as I was not equals to j, right? So we need to do the swapping as long as I is less than j. Now I want you guys to come back to this condition one more time later in the video. But know that this condition will work in this particular array where the array length is odd, okay? 5 length array, that means I don't need to swap the middle value. So as long as I is less than j, the swapping will occur. The moment I is equal to j, the loop will terminate and I will end the method. The method will stop executing. Now, how do we invoke this method in the main method? So over here, I don't have any array returning from my method. So I can just simply call my method and send my source array. I don't need to store it anywhere as I did in the out of base approach, because when I send source, I'm sending Uttara, and over here the array in Uttara is being altered. So when I come back, the source has already changed its value. Source points at Uttara and the array under Uttara has already reversed its values. As I said that we will be coming back to this condition because we have tested this condition only against an array that is of an odd length. Whenever you write a condition, make sure it works for all the possible combination of your input. Now, what if the array was of even length? Like over here, okay? The length over here is 6. So let's see whether this condition will still work or not. So initially, I will point towards 0 and j will point towards the last index. Is I less than j? Yes, I is less than j, so the swap will occur. After the swap has occurred, I will increase and j will decrease by 1. And then the swap will take place. After this, I will increment to 2 and j will decrement to 3. And then again, the values will be swapped. So after these values have been swapped, we can see that the array has already been reversed. Now, in the last instance, I was 2 and j was 3. So if the loop iterates one more time, I will become 3 and j will become 2. I will become greater than j. Do you think the loop will execute then? It won't, because my condition is the loop will keep on running as long as I is less than j. So when I becomes greater than j, this loop will not be executed. Hence, we can see that this condition works both for my array that is of odd length as well as my array that is of even length. Mind it that this might not always be the case. In this particular example, we saw that we got the condition correct in the first try. But in many scenarios, you will have to consider all the possible cases to see whether the condition that you have come up with works or not.